Okay, welcome. In these videos, we're going to now start to talk about equations involving absolute value. So as an example, consider the equation absolute value of x equals 4. And when we're solving these equations, like we're solving any equation, we're looking for all the values that would make this equation true. So any value we can put in for x so that the absolute value of it would be equal to 4. Well, to kind of help lead the discussion here, we've already talked about graphs. So the graph of absolute value would be the V-shaped graph starting at 0, 0 and then moving upward. And we're trying to see when that is equal to 4. And so if you look on here, there's actually two places where that graph crosses 4. And if we backtrack down, we see that that happens at both -4 and 4. And if you put either of those numbers in, the absolute value of 4 would be 4. The absolute value of -4 would be 4. And so we get our two solutions. In general, anytime you have an absolute value equation, absolute value of whatever, call it blah, equal to a number, then there's going to be two potential solutions. That would happen if the blah was equal to a, then absolute value would be a. And if the blah was equal to minus a, well then when you did the absolute value of minus a, you would also get a. So what we're actually going to do when we're solving these absolute value equations is really break it into two separate equations. And so to see this process, consider the equation absolute value of 2x minus 5 equals 8. We would break that down as 2x minus 5 equals 8. Since the stuff inside was equal to 8, then absolute value of 8 would be 8. And 2x minus 5 equals -8, because again, if the stuff inside was -8, then the absolute value would also be equal to 8. So then we proceed to solve each of those equations. 2x minus 5 equals 8. We add 5 to both sides. We get 2x equals 13. And then we can solve that equation by dividing by 2, and we get, oops, hold on, we get x equals 13/2, sorry I forgot to put the 2 underneath there. And then we proceed to solve the second equation. So 2x minus 5 equals -8, so you get x by itself. We'd add 5 to both sides. You get 2x equals -3. Divide both sides by 2, and we get our answer x equals -3/2 and x equals 13/2. Okay, so that's the process that we use. We break it into two equations. So let's consider a second example. Here we have absolute value of 4 minus 5x plus 8 is equal to 20. Now, there's a really important thing we have to notice about what we just did in the problem before. And that is, for us to rewrite that as absolute value equals 8, or the stuff inside equals 8, and the stuff inside equals -8, the absolute value has to be equal to a number. That's the only time we can do that. So, when we have this equation here where the absolute value is not by itself yet, we begin by getting the absolute value by itself. So we'd subtract off an 8 from both sides. Now that we have absolute value equal to a number, now we can say with full confidence that stuff inside could be equal to 12, or the stuff inside could be equal to -12. Okay, we can't say that when it was in the form above. So we would write down our two equations. 4 minus 5x equals 12. 4 minus 5x equals -12. And then we proceed to solve the first equation. So we subtract a 4 from both sides and then divide by -5. And then we proceed to solve the second equation. And again, as you're doing these problems and following along, you probably should try to pause the videos and work out each piece. So here we'd subtract 4 from both sides. Careful with your arithmetic. -12 minus 4 is -16. Divide both sides by -5, and we get x is equal to 16/5. Okay, so this is the start on solving these equations. We are going to look a little bit further in the next video at some more absolute value equations, and until then,